Hello guys, welcome to my YouTube channel, and in today's video I'm going to be explaining you how significant figure works. So let's get started. So behind me are two important numbers. First number is extremely big, whereas the second number is extremely small. So let us see what these two numbers are. So first number is number of atoms in 1 mole of hydrogen, as it is written there. As you can see, it's a very big number, and a very large number of atoms in 1 mole of hydrogen sample. Whereas the second one is very small number, extremely small number, and this number is the mass of one hydrogen atom. So as you can see, these numbers are extremely big, and in order to replicate them every single time in the paper, it would be very difficult for us to do so. So to solve that problem, we have developed a system called scientific notation, in which you can compress these numbers into a very small ones in the form of exponents, so that you could write in the paper and replicate it very easily. So let's see the definition of scientific notation. So scientific notation is also called as exponential notation. So it's called as exponential notation. So exponential notation or scientific notation of the numbers, in which it could be expressed in the form of n into 10 to the power small n, where capital N is the numbers between 1 to 10, whereas small n is the numbers of integers. So this is the definition of scientific notation. So numbers which could be expressed in the form of capital N into 10 to the power small n, where capital N is the numbers which lies between 1 to 10, whereas small n belongs to the integers. So let's do some examples to know how the system works. Okay, now let's solve the first example. I have written the basic definition at the corner so that it could be helpful for us to revise it. So let us see how we could write this in this form. So in the form of n into 10 to the power small n. So our main goal is to write this in the form of exponents, and this capital N should be the numbers between 1 to 10 and small n should be integers. So in what way if I express this number so that it gets converted into the exponential form? So let us see. So if I move this point to over here, the rule is 5, 6, 7, 8, 3, 7, 1 into 10 to the power. Since I have moved this over three numbers, I have to write it plus 3 because I have moved it towards the left. And if you move it towards the right, you have to write minus 3. And you have to make sure that if you multiply this number back, you should be getting this. So that is the basic and fundamental rule. So now let us check, does it obey the basic rule or not? So let us see n into 10 to the power small n. Now is this number where n equal to 5, 6, 8 something. So is this number in between 1 to 10? Yeah, absolutely. It is the number between 1 to 10. Whereas the small n is equal to plus 3. So it is an integer. So this is the scientific notation expression of this particular number. So let us see one more example. As I've told you, if you move the point to the left side of the number, you have to write plus in the exponential, in the small over here. And if you move the number towards the right, you have to write minus based on the number of numbers you jump the point upon. So now let us see, now to express this in between 1 to 10, I have to move this point in such a way that I have to get that number between 1 to 10. So I'll move it over here. So if I move it over there, I'm going to get the number as 7.3123. And since I have moved the number across 1, 2, 3, 4, 5, I'm going to write minus 5 because I have moved the number towards the right. Remember, if you move towards the left, you're going to write plus, and if you move towards the right, you're going to write minus. So this is the basic rule, and let us see, does it obey the basic scientific notation or not? So this is the number 10 power n, and n is equal to 7.3123, which is absolutely between 1 to 10. So yes, and small n equal to minus 5, which is an integer. So this is how we're going to express numbers in the form of scientific notation. So okay guys, let us solve a few more examples on this particular concept. So the first one is, so as you are familiar with this number, it is speed of light. So this number is speed of light. So we have to express this in the form of scientific notation, which is n into 10 to the power small n. So as you can see in the question, there is no point given here. But as you know, by default, if you have any number, say 57, the point will be over here. So my point will be over here. So 0.0 something I can take. So I have to move this number over here. So I'm going to move this number over here and write it. So 2.9979248 into 10 to the power. Since I have moved it towards the left, And across how many digits? 1, 2, 3, 4, 5, 6, 7, 8. I'm going to write it as plus 8. It's that easy. It's extremely easy. You just keep doing few examples, you will get it off. Okay guys, now let's solve the second one. So as you are familiar with this number, so this is Avogadro number, the number of entities in 1 mole of anything. So as I took this for the introduction also. So by default I can say the point is over here, 0.00 something. Now I have to move this point over here in order to get a number between 1 to 10. So I'm going to write it in such a way that, so 6.022, since everything is 0, I don't have to mention all that. So into 10 to the power, how many numbers have moved upon? 3, 6, 9, 12, 15, 18, 21, 22, 23, 23. So plus 10 to the power 23. Why plus? Because have moved the point towards the left. Remember, if you move towards right, it is minus, whereas if you move towards left, it is plus. This is the basic rule. So let us solve the next one. So this number is the mass of one hydrogen atom in grams. So as you know, the point is already given over here. So in order to make it into a scientific notation form, so I'm going to move this point over here in order to get a number between 1 to 10. So I'm going to write this as 1.66 into 10 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 2 to the power minus 24. Say suppose grams. So let's see the final example. So as you can see, it's already written in the form of scientific notation. So let us see how it is. So n into 10 to the power n. So your n is 3.1415, which is absolutely in between 1 to 10. Whereas where is your 10 to the power n? Can I write this number as 10 to the power 0? Because 10 to the power 0 is 1, and multiplying 1 with the number doesn't matter anything. So this is the scientific notation expression of, I'm going to write it over here again, 31415 into 10 to the power 0. So this is the answer for this particular question. So this was the whole video. I hope you guys understood the concept. And if you learned something new, make sure you subscribe the channel and hit the notification bar. So I'm going to meet you in the next video. Thank you.